So 300 centimeter cube of a gas at 27 degrees Celsius is heated to 127 degrees Celsius at constant pressure. Calculate the new volume. So we're talking about Charles' law here. So given that my initial volume is 300 centimeter cube and my initial temperature is 27 degrees Celsius, I must convert it back to Kelvin, which is 27 plus 273. So it is 300 Kelvin. My final temperature, which is 127 degrees Celsius, I will convert it back to Kelvin, which is 127 degrees Celsius plus 273 to give me 400 Kelvin. And my pressure is constant. So writing the Charles law equation, which is V1 all over T1 is equal to V2 all over T2. So my V1 is 300 centimeter cube all over my T1, which is 273 Kelvin. Sorry, which is 300 Kelvin, and is equal to my V2 is unknown, and my T2 is 400 Kelvin. So I have to cross multiply, which is V2 equals to 300 centimeter cube multiply by 400 Kelvin. After I multiply it all over 300 Kelvin, so the Kelvin will cancel Kelvin, so 400 multiplied by 300, so the 300 will cancel the 300, so my final answer is 400 centimeter cube, and that's my final answer for the new volume. So that's it. So the second question is: a gas occupies 2.5 dm cube at 15 degrees Celsius and constant pressure. So at what temperature in degrees Celsius will the volume become 3.0 dm cube? So let me write the equation out. That is, given that my V1, that is my initial volume, is 2.5 dm cube and my initial temperature is 15 degrees Celsius. So I have to convert that 15 degrees Celsius back to Kelvin, which is 15 plus 273. Which is 288 Kelvin. And my final volume is 3.0 dm cube. So let me write the formula out. And we are talking about Charles law because the pressure is constant, so the P is equal to constant. Now writing the formula out for Charles law, I have V1 all over T1 is equal to V2 all over T2. So my V1 is 2.5 dm cube all over my initial temperature, which is 288 Kelvin, equals to my V2 is 3.0 dm cube and my temperature is unknown. My final temperature is unknown. So if I cross multiply, so my T2 is 288 Kelvin multiplied by 3.0 dm cube all over 2.5 dm cube. So the dm cube will cancel each other. So my T2, that is my final temperature, final temperature is 345.6 Kelvin, and they said you should convert it back to degree Celsius, which will be 345.6 minus 273. So our final answer is 72.6 degree Celsius. Now, the third question is: a balloon contains 250 centimeter cube of air at 27 degrees Celsius. It is placed in a freezer at minus 23 degrees Celsius at its constant pressure. What is the new volume of the balloon? Now, solution to this: given that my initial volume is 250 centimeter cube and my initial temperature is 27 degrees Celsius, which means I have to convert it back to Kelvin. 273 plus that 27 give us 300 Kelvin. Now my final temperature is minus 23 degrees Celsius. I must convert it back to Kelvin. That's minus 23 plus 273 will give me 250 Kelvin. And my pressure is constant. I'm not converting this one back to degrees Celsius, just like the number 2 question. Now let's go. Charles' law formula is V1 over T1 is equal to V2 over T2. So my V1 is 250 centimeter cube over my T1, which is 300 Kelvin, is equal to my V2 is unknown and my T2 is 250 Kelvin. If I cross multiply, my V2 will be 250 centimeter cube multiplied by 250 Kelvin all over 300 Kelvin. So the Kelvin will cancel Kelvin. Now let's move. V2 will be equal to, that's 250 minus 250. I have 208.3. That is when I divide that one with 300k. So it's either I have 208.3 centimeter cube or I have 208 centimeter cube. Thank you.